And recording begun. Okay, so let's bring up the agenda. Okay, for those of you who are new or don't have I don't see anybody who's new, but don't have the agenda or the minutes there in here. And I think for this meeting, we wanted to start with an overview of KVC.
Hello.
Hello.
So this is Balaji here. I added that.
Okay.
So this comes in from the first meeting where we talked about user pain points from the interviews that we did with data scientists. So let me start sharing my screen. I have already put a link to the repository as well as the slides to the meeting notes. And by the way, if you don't have access, don't request access. Just join the mailing list for ML working group. You will have access to it, access to these slides. Are you all able to see this presentation?
Yeah, we can see it.
Perfect. So this presentation is about Kubernetes Volume Controller, or in short, KVC. This repository is currently a part of the KubeFlow organization, and I'm Balaji Subramaniam. Ajay Deshpande, who's also has joined the call, is the co-author of KVC. We are both from AA Products Group or AAPG with an Intel. So to give you an overview of how this project started, we talked to some internal data scientists and machine learning practitioners. So there are some different types of user categories that we talked to. Some of them are researchers. They did basic research in machine learning, like optimizing models, what type of models to use, any kind of new direction in creating models, so on and so forth. There were also ML practitioners. These are the folks that took some already existing techniques and applied it to some business use cases. So they were primarily concerned with making a service or a product that would better suit a customer requirement. And third part is the DevOps engineers who actually support the infrastructure used by the researchers. So start off with, I want to give a brief overview of the ML workflow that's being used. The first part of this is iterative training, where there needs to be some code changes need to be done by the user, by the ML practitioner or the researcher, in order to get to a model that better suits their needs or requirements. So what they would do is they would have some model parameter input, they would make some code changes, run the model training process, then it spits out some output. If the output is what they expect, then they just move on. Otherwise, they would again try to iterate this process over again by making some more code changes and adjusting their model to suit their needs. So this is just illustrating that they would use the same iterative process with some other values in it. The other workflow is the hyperparameter optimization, where there are the user wants to run the same model, same model training script or code with different hyperparameters, and they want to look at which which hyperparameter gives them the best output. The best output is dependent on metrics like the accuracy. For example, it could be also time to accuracy in some cases. And what the typical workflow looks like is they spawn a bunch of jobs on the cluster and then figure out which one gives them the best output. So what we really saw was some kind of a workflow, but in each cases there is some data component involved. Data is an important component in this workflow. So the blue boxes in each of these cases are the data associated with both of these workflows. One of them is iterative training. The other one is the model training output itself. Even in hyperparameter tuning or hyperparameter optimization, the same applies. So, okay. So at the start of this working group, maybe in the second meeting, we presented a bunch of user pain points related to different user pains, like our user pain categories, like for example, data or scheduling. So in this case, I've just picked up some user pain points, which are the basis of or the motivation for creating Kubernetes volume controller. So the DevOps engineer wanted to pre-seed frequently used datasets and models from different sources locally so that it can be used by users in their group. So these frequently used datasets are like very popular models like ResNet or a dataset like CFAR or ImageNet or Inception V3 or some of these. It could be either a model or data itself, which could be used for training. We also wanted the ability to use data sources that are not natively supported in Kubernetes, for example, S3. Then the ability to track, use, and manage these data and models from different sources in their experiments was a key requirement. The other part of this workflow is that the user categories that I mentioned can be like involved in multiple stages of this workflow, like where the data could be either, if the user is, if the ML practitioner or the data scientist is developing, they might have their own data set, which needs to be either locally cached or made available either through PV or PVCs so that the job could consume it, or it could be where like there should be a handover, like where an operator could prime or cache the data sets that are frequently used, data sets and models that are frequently used in the cluster. So this kind of these different types of categories of user could be involved in any of these stages, and multiple user types can also be involved in the same stage as well. So we created KVC to solve some of the user pain points that I just mentioned. So what is Kubernetes volume controller? KVC leverages the operator pattern to manage data in Kubernetes. So KVC handles data from different sources such as S3 and NFS, for example. We also have some source types related to Pachyderm file system now. KVC maintains the metadata required to establish the relationship between data and volumes in Kubernetes. So start off with, just to go a little bit more deeper. So what we really did was use custom resource definitions. So we extend the Kubernetes API server with a resource called volume manager. So we load custom controllers to drive these Kubernetes resources. In this case, the volume manager to desired state. The current status is that we support some data source types, and you can look at our repository in order to get more information of what we support. So a typical or a user journey that could be supported by KVC is this. I'm a researcher on an ML practitioner. I have some data in S3. I want to download it and replicate it across multiple nodes in my cluster. I want to also label them so that I can remember and keep track of them. So what this replication does is allows you to run like one use case where people use this is to run hyperparameter optimizations where it's replicated in different types of nodes. If right now KVC doesn't support sharding, if sharding is supported, it can also be sharded and distributed in the right way. But people also use it for distributed training now, where the data is replicated among all the nodes. So they can also, if one person creates this custom resource, they can also be shared with other coworkers. So how S3 data source type in KVC works is that when you create custom resource, you specify the source type or the data source type, some labels, the location of the S3 bucket, and the number of replicas you wanted to do. Sorry, this is not the labels. These are the labels. So when the CR is created, what typically does it, the custom resource goes into a pending state and the controller takes over from there. The controller looks at the custom resource that was created and downloads the data using pods and scheduler, the Kubernetes scheduler. And when the download is completed, it will provide you with a volume source. In this case, it would be a host path volume source and the node affinity details in order for you to guide your pods, whether they are part of a job or a high-level object like either a deployment or a job in the cluster. If the download fails, or if for some reason there is some other failure, the error is bubbled up to the custom resource so that you have a single place in order to look at whatever errors that might occur during this download. This is just for one source type, but there are also multiple source types within KVC. They are all behind an interface, so you can implement the interface in order to get support for a new data source type. Also, you can specify multiple source type within the same custom resource. So we have recorded a video link here. I'll just go over this. Okay. So in this cluster, we have already installed the controllers required for KVC to operate. So the controller is already running. When the CRD is also already installed. And the kind for the CRD is volume manager. When you start off, there is no volume manager custom resource, KVC custom resource in the system. So this is a typical YAML for the S3 source type. When you look at it here, there is a bunch of labels here. There are options which will provide the credentials as a part of a secret in order for us to get access to the data itself, the source URL itself, and then an endpoint URL. The endpoint URL is added because we support any, I wouldn't say any, we support three different S3 compatible storages, AWS S3, GCS, and MinIO. We use a MinIO client, so we have to specify an endpoint URL in order for it to download from different S3 compatible storages. So this is a typical custom resource. So when you create the custom resource, what it would really do is simply like run multiple pods in the cluster. In this case, the replica is just one, so it'll run like a single pod and download the data on a set of nodes and provide you with the volume source and the node affinity required in order to consume that data when you're running a job. So we create the custom resource that was just shown here. And when you do get volume managers, you see that the custom resource was created. And when you actually describe the the volume resource that was just created, what you will see here is the volume source, which has sorry, let me just get out of here. So which has two things. One is a volume source which has host path, and then the node affinity details to land on nodes where there is some where the data was downloaded. Next, we'll show some example pods where you can add these node affinity and mount this host path volume source in order to consume that data. So this is a simple pod where we have already added the node affinity details. We just add the host path details, and when you run this pod, you will see that you will have access to the data with the node affinity, which is an already existing primitive in Kubernetes. We are able to guide the pod towards a node where the data is already downloaded. So that's it for the video, and the video is also linked in the slides. If you don't have access to the slides, please join the ML working group mailing list and you'll have access to the slides. So yeah, so there is also the effort related to container storage interfaces, CSI in Kubernetes. There are certain things that are missing, but probably in the future releases, they will support these things. So the first thing is volume topology support is not, volume topology is not yet supported in CSI.
What do you mean by volume topology?
Hello, say that again. I didn't understand.
Can you clarify volume topology with respect to CSI?
So volume topology is a feature in Kubernetes, like I can show you. So
the one Michelle's working on?
Yeah.
Oh. Okay, so volume topology in the orchestration generally lives more in the scheduler and the provisioner than it does
right.
in the CSI layer. So what would you need in CSI for that?
No, you wouldn't need CSI for that. I understand that, but you have to pass in the node affinity information CSI. So
yeah.
node affinity can be taken care in the scheduler. Yeah. However, like that's the problem there. I mean, it's not a. I'm not saying like It's not a negative criticism of CSI. I'm just saying it's not supported yet, but in the future will be supported.
Right. I wasn't taking it as a criticism. I was just asking for clarification. Thank you.
Okay. Sorry. Okay. So the other issue is that this might be when you distribute, like, so for example, data and cache them locally in a cluster. So what we have seen is so when you request when you volume mount a PVC in a high level object like a job, you can specify only one volume mount, but this volume source is actually similar to local PV. What I mean by that is, so the volume, the data, the local PV is associated with a node, and when you do that, assuming that the pod lands in different nodes on the same high level object, you might not be, the pod might not start running because it might not land on the same node where the local PV was provisioned. So this is a problem where we may need to have a choice of PVCs, like the user could specify multiple PVCs in the pod template spec. However, if we are able to attach to one of them in any of the nodes, then the pod might start running, something like that. Maybe a solution like that would be useful. The other problem is, I think they're working on it, the CSI driver installation. How do we deploy the plugins for CSI? Then the other miscellaneous comment here is, I don't think Kubernetes has support for, or maybe even thought about thought about adding support for object storage yet. So those are the couple of issues that are outstanding within container storage interfaces
So
that make us, yeah.
just for the PVC and PV issue, that's like under work. So local PV should actually have gravity and pull the pod. Like if you add a PVC to a pod and it
I know,
corresponds to a local PV, it
I
should
know.
pull the pod to the node.
Right. So this is one more requirement on top of that. So let's just say there is a deployment that uses a local PV. Okay.
Mhm.
And assuming that all the pods or all the replicas in that deployment are not able to land on the same node, then the rest of the replicas won't run at all because this is attached to a single PVC, and that PVC is bound to a single node.
Right. What you'd want to do for something like this, for something like, so if you're trying to do distributed training, what you really want is some combination of job and stateful set.
Yep.
You'd want an individual PVC that's generated for each pod, right? You don't want to try to mount them all to the same PVC, even though the PVC is backed by the same actual data. And then
Right.
you'd want
Agreed.
more of
So
something like a job because you want the pod to run to completion, either success or failure, not something that continues to be restarted indefinitely.
right. So in a job, I know. So in a job, when you do this pod template spec, so the pod template spec is same for all the pods. And when you mention one PVC in that pod to volume mount, and that PVC happens to be a local PV, let's just say, and it has node affinity associated with it. If the other resource requests are not satisfied by the same node, the pod has to land on a different node, and it won't be able to land there. You know what I'm
Right.
saying?
What I'm saying is like if you wanted to do it this way, right? Like if you wanted to specify a PVC in order to leverage local PV, you'd have to specify a different PVC for each member of your
Right.
pod group, right? Like you
Right.
wouldn't want to, even though these in the use case you're specifying, all of the volumes are going to contain identical data, you'd want each one to have a separate PVC, which is kind of like how we're looking at doing it for stateful set, for instance, to get
Okay.
stateful to integrate with
Makes
local.
sense. Makes sense. That's what I'm saying. Like that kind of a feature would be very useful. In case of so I'm just talking about the current state of any high level object within Kubernetes, like a job or a deployment, where if you specify this in a pod template spec, like a volume mount, a single local PVC,
Yeah, it's not going to work because you
it's
get
not going to work.
Yeah.
Exactly. And continuing with my presentation. Oh yeah, so that's all I had. So the demo video link is already there. We only showed S3, but take a look at our repository, and if you have any feedbacks and comments, please open some issues. The contacts are also listed. We wrote a blog on this. If you want to look at the blog, you can take a look at the link. And that's it. Thanks.
Cool. Thank you for sharing that. That's really awesome. I did have one other question. So what's the auth mechanism for accessing the S3 bucket? How are you distributing credentials? Are you just
Using secrets.
Go ahead.
Secrets.
Okay, so you're using Kubernetes secrets.
Yep.
Okay, cool.
And so currently we are working on, it's in progress, the Pachyderm file system, or there is a Pachyderm is a ML workflow in Kubernetes, and Pachyderm is an ML workflow or workflow software which also uses Kubernetes, and they're trying to they're using KVC as a data glue between Kubeflow and Pachyderm file system itself. And there are also opportunities to add other data sources if it's required that are not natively supported. I've had some requests for HDFS, but we have not had time to work on it yet. And
Cool.
The other part is to make it all simpler, as in like you don't have to copy, or to make it all easier for people to consume these KVC custom resources. We're trying to add a webhook. Webhook is actually an admission controller. So what you would do is you would specify in the label name what KVC CR that you want to associate yourself with, and the admission controller would actually mount or rewrite your pod template spec or pod spec itself, and mount all the KV volume sources associated in the KVCCR during admission time. That's it from me.
Cool. Anybody else have any questions, comments, thoughts?
Only comment I have is nice work, man. Good stuff.
Thanks.
Cool.
Actually, I had a sorry.
Yeah, please go ahead.
Okay. Sorry. You mentioned that you want to add support for HDFS as well. What would that look like? Because it's still not super easy to support that in Kubernetes.
Yeah, we haven't thought about it yet. I know it's not easy to support that in Kubernetes. Yeah, we haven't really dealt with. I mean, that's why we have been procrastinating on it, I guess, because it's kind of murky on how to deal with within the Kubernetes environment.
There's actually been a lot of discussion about HDFS, more in relation to Spark, but in SIG Big Data. And in particular, the Pepper Data guys are interested in working towards better integration for HDFS on Kubernetes.
Okay. How would CSI play a role there? Like, I want to know, like, in case of CSI, would it be possible? Like, I mean, I see CSI as like a.
I don't think CSI would play a role there. You can, so there is a proposal to actually mount Kubernetes PVs that are backed by HDFS, but the latency and throughput you get on HDFS really isn't what you'd want to see for a PD, for network attached storage. On the other side of it, we want to, so like depending on how your network is actually set up, you get data locality issues. And the main use cases for HDFS is like, basically I want to set up a bunch of processes that are all going to read from replicated partitions across the cluster. But I want to be able to schedule my pods close to the partition that they're going to read from so I don't have to take the extra network hop. Now on GCP, it's not as big of a deal. The network, like we did some experiments and the network is actually fast enough that data locality it really didn't matter. Like setting up with a custom node topology so that we were able to achieve data locality didn't drastically improve performance for read over just throwing them randomly across the cluster. If you're more concerned about running it on-prem or on places where the network isn't quite that over-provisioned, then data locality is going to become an issue. Like AWS, it was definitely an issue, and you could notice degraded performance. The challenge is really being able to expose the correct network topology for the nodes. And Pepper Data has actually put some work into doing this. And then the other side of it for HDFS is there are people who are running KH clusters and HDFS side by side in the same footprint. So basically, like you'll have KH one portion of the rack, and then you'll have HDFS on another portion of the rack on storage dense nodes. And they've had some level of success doing it that way. So you're not going to co-locate directly onto the same node as your data, but you'll co-locate on the same rack, and you're just going to have to go over the top of a rack switch in order to access the data for the HDFS cluster. So good results there, but I definitely encourage you to reach out to the Pepper Data guys or maybe go to SIG Big Data. They meet on Wednesdays and just talk to them about it, because if it's something you're interested in working toward, it's definitely something they are interested in working toward as well.
All right, thanks.
Okay, we didn't really have anything else scheduled for the agenda. Does anyone want to talk about KubeCon? I see Jeremy hiding there. Did you want to share a little bit about Kubeflow at KubeCon, Jeremy?
Sorry, I was finding my mute button. Okay, let me pull up my notes. So there was a lot of interest in Kubeflow at ML more generally at KubeCon, so that was great. There's a lot of
Jeremy, you want to up the volume a little bit.
Okay, let me try that. Give me a second. I'm trying to figure this out. Mic volume. How's that? Any better?
Yeah.
Okay. Let me pull up my notes. Sorry. So had a lot of great conversations with people like Rise and Mal. So they have a great tool. Hopefully they'll participate. Great to get that into find some way to integrate with and work with them. We had a lot of discussions with Michal and William about sort of the simplifying sort of the workflow for data scientists in terms of building if you modify your code, build your container, and then submit like a TensorFlow job for that container. So we're looking at trying to use, hopefully get some experiments going with tools like Scaffold and Draft to see how much and what already exists we can leverage. Let's see, give me a second to pull up my notes. Let's see. So we had a number of folks. We're pretty happy with the number of folks who signed up as part of the Kubeflow community. So I think we have over 20 plus organizations now listed. So that's pretty exciting. I was pretty excited to see Eclipse Chi now works on Kubernetes. I'd love to get that integrated as part of the Kubeflow story to have a good IDE to support that use case. We had Kai Cloud shared some notes about some feedback and UX research they had with data scientists. So we should, if anyone else is interested, I'd encourage you to reach out to the Kai Cloud folks and ask them if they're willing to share that. We chatted with One Convergence. They've done a number of improvements to the UI in Kubeflow, and also I think they added OAuth support to Ambassador, which is really nice. So we're hoping that they upstream those changes and get that into Ambassador, and then those UI improvements to Kubeflow. That'd be fantastic. And then I spoke with a company called .mesh, and it seems like, from what I understand, they have a versioning system for data that works with K8's volumes. So if I understand correctly, it's supposed to allow you to do things like create a PVC and say, I want this snapshot of the data, and then it'll automatically copy the data to that PVC and make it available. So that sounds like it could be very useful, and yeah, so that sounds interesting and promising. That's pretty much what I have.
Cool. Thanks, Jeremy.
No problem.
Also, if you guys, do you know if the keynotes are public?
Hopefully.
Okay. So if the keynotes are public, you might want to check out Vish, Jeremy, and David's presentation on Kubeflow that was presented at the keynote by Vish and David. Which is pretty cool.
Yep. Yeah, we have all that code in the repo somewhere. I think it's still in a private repo, but I expect we'll make that public at some point. It's mostly just a question of cleaning it up. Great.
Cool. All right. Okay. Does anyone else have anything they want to discuss for this meeting? Okay. I'm going to take silence as a negative. All right, then I guess that'll be it for this week, and we'll get 15 minutes back. The only thing that it looks like we have laid out for next week at the moment is, or I'm sorry, not next week, but bi-weekly, is an overview of FFDL from IBM, I believe. Yes. And it's deep learning fabric, which promises to be interesting. All right, guys, and have a good day, and I'll see you in a couple of weeks.
Take care.
Thank you.
Thanks.
Thanks.